Alright, so in this video we're going to discuss the four quantum numbers. Now this is where things are difficult until you get it. Once you get it, you got it. And once you got it, you're good. Because I'll start asking you questions and you'll be like bam, 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 just spitting it out and throwing it out. So don't get frustrated with it at first. You'll catch on and you'll be fine. Just take it easy, ask questions if you got them, come see me. Remember, pause the video, take good notes. Take some really good notes off of these. Alright guys, so let's get started into this. So let's start off with these four quantum numbers. The first one we're going to talk about is the principal quantum number. Okay, the principal quantum number, and it is abbreviated by a lowercase n. So that's the abbreviation for, excuse me, that's the abbreviation for a principal quantum number. Now, n, a principal quantum number, can carry a range of 1 to 7. So the number's 1 to 7. And it will be a whole integer. It'll never be a decimal. It'll never be a fraction. Always a whole integer. Now the purpose of the principal quantum number is it gives us two pieces of information. The first piece of information it gives you is it talks about the shell. And the shell is kind of like, you know those energy levels we talked about? That's what these shells are. So this talks about the shell. And the information it will give you is the size of that shell. So it will tell you all about the size. So this is about the size. We'll do it like this. The size of the shell. That's the first piece of information it will give you. The second piece of information that this will give you is your energy level. Alright, so here, let's go energy level. Remember all those configurations we did, the orbital notation, electron configuration, all those, that's what this is talking about. So what I'm saying is you look and say, Mr. Hall, why do we care that we got 3 orientations and it's a 3p? Okay, that number 3, guess what? That's N. Right there. How about that? The number 3 is N. Okay, that's a horrible P. I'm going to fix that. Alright. So that's what the principal quantum number will tell you. So let's move on to the second. Okay, the second one is the angular momentum quantum number. Now the angular momentum quantum number will give you pieces of information as well, but this deals with subshells. So these deal with our subshells. Alright, these subshells are these actual orbitals inside of there. That's what we're talking about here. This will tell us what it is. Now it can carry a range. So its abbreviation is a cursive L, a cursive lowercase l that is, sorry. So it can carry a range of 0 to n minus 1. Now, truthfully, you'll never exceed 3. And I'm going to tell you why. So if L, and with you taking your notes, make this look like a landing strip. For some reason, this is the biggest, hardest issue that everybody seems to have. But it's the simplest idea with it. If L is equal to 0, then let's just do this. L is going to be 0, 1, 2, or 3. And what this will tell you is the shape. So, if it's a 0, guess what? It's an S orbital. If it's a 1, it means it's a P. If it's a 2, it means you're dealing with a D. If it's a 3, you're dealing with an F. So it tells you the shape. That's the piece of information that the angular momentum quantum number will give you. So tells us the shape. Alright, whenever we get to class, I'm going to show you these different shapes, and I'll show you some different orientations of what they can look like. And they can get really interesting. Which will bring us to our third quantum number, the magnetic quantum number. This one is abbreviated M sub lowercase cursive l. So ML. Now ML is the interesting one. You know how many times y'all looked at me and said, Mr. Hall, which by the way, sorry I should have mentioned this, my bad. You see this? The subshell telling you about the shape? Look here. You see the P? Look at there. There's the P. L gives you P. It'll give you the shape. Okay? So back to the magnetic quantum number, M sub L. M sub L can carry a range. So M sub L has a range of negative L, which is the angular momentum quantum number, to L. Just positive L. Just regular L. The angular momentum quantum number. So it's dependent on that. So jumping off the example we have up here, how many times y'all asked me in class, why is there 3 dashes, Mr. Hall? This makes no sense. I'm not understanding. The reason there's 3 is because there's 3 different orientations. Because if you'll work this out, and you look, if L is P, that means L equals 1. If L equals 1, that means we have the range for the magnetic quantum number, M sub L, to be -1, 0, and 1. So like I told you, up here, this was the -1 orientation, this is the 0 orientation, this is the 1 orientation. Alright? Now the magnetic quantum number gives you a piece of information as well. It gives us the orientation. If I misspell this, I apologize. Oh well. Gives you the orientation. Okay? So, these orientations come from here. If I can draw a nice little line going through here up to these orientations. Alright. Now those are the major 3. The last one is the spin quantum number. Electrons have to spin in different directions. Why? Because they're like charges. So they have to have something to overcome the natural repulsion force that's happening from the like charges. So what they do is they spin. And what it will create is this electromagnetic attraction force between those electrons. And it's abbreviated M sub S. Alright? So M sub S, it does not carry a range. It is either one or the other. It's either +1/2 or -1/2. Remember how I told you guys when we did the orbital notation and these arrows? While one would have to go up, that would be the +1/2, and one was down with the -1/2. That's what we were talking about here. You have to show the spin. Okay? You have to show the spin because it deals with the quantum entanglement. And we'll talk all about that when we get back to class. So make for sure to go back through, watch this video a couple times. Make for sure and take good notes. You better come to class with good notes. You need to have the good notes because we're going to start jumping in and working with these numbers. Because we're going to take these numbers and apply it to elements off of the periodic table. So make for sure to come, because we're going to ask you questions. Well, I'm going to ask you questions like carbon. And you're going to have to produce answers for that. So like a question can be, what's the 4 quantum numbers for carbon? You're going to have to be able to produce we needed that periodic table. There's a 2, 1, okay, 1, 0, and plus 1/2. That's carbon. You're going to have to be able to do these. Okay, we're going to work with them. This is where I'm talking that you'll get this, and once you get it, you're good. Until you get it, you don't have it. I know it sounds confusing, because it is. Just come to class with questions, ready to go, because I'm excited. I love quantum numbers. This is going to be some fun. You guys will end up loving it.